What's going on, everyone? Welcome back to Fabian Electrical Services. On this channel, we break down real electrical work, real code rules, and real job sites. Real code rules and real job site situations. No guessing, no shortcuts. Tonight, we're going. Sorry, my speaker was a little bit low, people. What's going on, everyone? Welcome back to Fabian Electrical Services. On this channel, we'll break down real electrical work, real code rules, and real job site situations. No guessing, no shortcuts. Tonight we're going into breaker sizing, troubleshooting, grounding, and I'm going to show you exactly how this applies in real installation. If you're an electrician, apprentice, or even a homeowner trying to understand your system, you're in the right place. Let's get into it. Most electricians get this wrong, especially when it comes to breaker sizing. And this is where inspection fail or breaker trips. So pay attention to this. So again, welcome back to the channel for all those who are tuned in. If you guys are tuned in from YouTube, don't forget to don't forget to tap on the tap to like up the live stream. Very important. And again, for all those who are over on Instagram, don't forget to like up the live stream also. Please and thank you. Very important. So we're going to get into tonight's stuff here. I'm going to be putting up some banners as I go. So again, welcome back to the channel. Thank you guys all for tuning in to tonight's live stream. And again, so we're going to go right into it. So this is basically going to be code rules breakdown. Rules 81-4, load calculations. Rules 14-104. I'm going to put it up on the screen so everyone can see for those who are tuned in to tonight's live stream. And again, rules 8-104. I'm going to show you what it exactly it states. Rules 8-104. So let me pull that up here. I'm going to go through some rules here. So again, this is 8-104, and it says maximum circuit loading. Continuous loads shall not exceed 80% of the circuit rating. Non-continuous loads may be loaded up to 100% of the circuit rating. A continuous load is any load expected to run basically more than 3 hours. So that's basically a continuous load. So your continuous load is going to run more than 3 hours. It's going to keep running constantly. So that's what they mean by continuous load. Again, that this is right out of 8-104, and this is what we normally have to go by. This is where you're going to get your 80% rule and so on. Again, for all those who are tuned in to the live stream, don't forget to like up the live, please and thank you. Helps with the channel. So again, if you are late, if you're just tuning in, you are tuning in at the right time here. And again, this is right out of code rule 8-104, and it simply says maximum circuit loading. Continuous loads shall not exceed 80% of the circuit rating. Non-continuous loads may be loaded up to 100% of the circuit rating. Non-continuous loads may be loaded up to 100% of the circuit rating. A continuous load is any load expected to run more than more than sorry here, people, more than 3 hours. That's basically what a continuous load is. So the reason why I put this up on the screen, I had feedback from one of my subscribers, and they said maybe the I should put the banner on the actual screen so you guys can actually read along. So again, thank you for pointing that out to me. So that's why you see I have this up here so you guys can see it. And again, I'm wondering if you guys can actually hear me. I don't know if you guys can hear me. If you guys can hear me, I don't know, just like up the live stream. So that is continuous load. And also, I'm going to pull up the other one here that there's another rule here. And again, I'm not sure if you are seeing that properly here. Let's see here. This is basically talking about the overcurrent device are intended to protect conductors, not the equipment. So again, your overcurrent device, I kind of can't see. I have the light right in front of me here. I'm wondering. What is going on here? Okay, so it says it's clear as day here. Appendix B clarifies that overcurrent devices are intended to protect conductors, not the equipment. So a lot of times people misunderstand the rule, and again, it is there to protect the conductor. The breaker is there to protect the conductor and not the actual. Um, so it is there to protect the conductor. It's not there to protect the equipment itself. So don't get it confused. That's what the rule is basically there for. Again, the rating of the breaker or fuse must be selected based on conductor amplicity, considering conductors such as um, temperature, and so on. You have to uh, keep that into effect. I'm just going to try to remove the actual banner here so you can actually see the so there you go here. So the rating of the breaker or fuse must be selected based on the conductor amplicity, considering conditions such as temperature rating, insulation type, and insulation methods. So that is what the rule states there. So what I'm going to do is I'm going to remove that, and I wonder why no one is seeing me here. Okay, so I'm going to remove that there for a second here. I'm wondering why my screen is doing that. I don't know here. It seems like it's a little bit slow here. I'm not sure what is going on here. Okay, there you go. Okay, so that was basically the rule there for the actual. Oh, okay, I know what I did there wrong. Okay, so I'm going to put another rule on the board here. So again, for all those who are tuned in to the live stream, again, thank you guys all for tuning in. I'm going to try to put back this banner right here. Let me find it here. So again, this is what we're dealing with right now. Code rules breakdown examples. Again, for all those who are tuned in to the live stream, don't forget to give it a like as you come in. Okay, so that's the code rule breakdown examples. It says rules dash 104, load calculations, rules 14 dash 100, overcurrent protection, 80% rule continuous. Again, what that is basically when you're loading your circuits, there is an 80% rule that you have to keep into effect, and you cannot go over the 80% rule. 80% rule is kind of vital for the installation, for the whole circuit to run correctly. When the circuit runs smooth, you have no problems, you have no overheating and so on. You don't have any of your breakers tripping. So I'm going to go over to rules 14-100 where it talks about the actual overcurrent protection. So let's go to that one here. Okay, so that one is done. So OESC rule 14-100, overcurrent protection. Each underground conductor shall be protected by an overcurrent device rated or set at not more than the allowable ampacity of the conductor. No. So hold on a second here. I just want to check something here. Okay, so each underground conductor shall be protected by an overcurrent device rated or set at not more than the allowable ampacity of the conductor. The overcurrent device shall be capable of opening the circuit under fault condition. So it says the overcurrent device shall be capable of opening the circuit under fault conditions. Basically means you don't want any false conditions. You want it to be able to open without having any issues. You want the circuit to run smooth without having any issues at all. So I'm going to, so again, this is segment 2 here. Again, this is code rule breakdown, rules 8-104, load calculations, and rules 14-100, overcurrent protection. And it also goes on to say, you know, this is where guys get it wrong. Again, rushing, not wanting to do certain things in order to get the job done. So I'm just going to run a short clip here of past work that will show you. Again, I'm not going to run the clip for too long. It's going to be a couple seconds or so, and then I will
I'm still working on my installation of my new panel. So what I'm going to be doing is clearing this.
So basically what this is basically preparing your circuits and so on for the actual job itself. And again, how you go about this process is you have to make sure your circuits are all on the your circuits are all evened out. Your circuits are not going to actually cause a problem at the end of the job. So again, you want to make sure that you get this done correctly and avoid all necessary
the normal way. So now this is
problems at the end of the job. So
because there's a code
again,
rule that
this is
states
normally
that
how you go
your
about the
breaker has to
process.
be a certain height. So
You
this
have
is
to figure
within
out
my
your
certain height,
circuits, you
so I
have to
can
label
take
your
this panel
circuits
and
and so
flip it the
on.
other way, and that's exactly what I'm going
And
to do
that's normally how
to
you
make
would
this
mount
work.
the panel. Once you
Okay,
mount the panel,
just
we're
going
going
to
to
knock out this
turn,
installation.
cut your wires into the panel,
That
make
way,
sure
once I
that
install my
everything
panel,
is
I don't need
done
to play
according to
around with
code.
here
And
because it's
when
going to
I
give me
say according
problems.
to code,
So
make
the
sure
key
that
to installing
your
a panel
circuits are, you have maybe
fast and efficiently is to prep everything.
eight
Make sure
devices
that
per
you
circuit.
don't forget the
You don't
simple
want to
stuff that you
max
need
out.
to
When
do
you
before
max
you
out,
install
it
this
kind of
panel.
causes
This will
issues,
be one of them.
and that's where you're going to
So
run
that's
into
basically what I'm doing
the
in this
rule
video.
8-104,
Also, please like, share, and
where you're
subscribe
not
to my videos, and leave a
following
comment in the
that
comment section.
actual
Thank you.
rule, and
Okay, two
14-100.
wires
So
into
this is
one
where
format.
the rules comes from, and this is how we
So
apply
the
it in
trade name
everyday
this
life.
format
So
is
that's just a
basically
short
the connector.
example. Again, I would like to thank you guys all for tuning in to tonight's live stream. Again, also, don't forget, as you guys enter, don't forget to like up the live stream. So again, on that example, you can have round breaker size, overloading of the circuit, misunderstanding your continuous load. So again, very important not to misunderstand the continuous load. You don't want to really get into that kind of situation when you are misunderstanding the actual load itself. So again, welcome back to the channel, and I'd like to thank you guys all for tuning in to tonight's live stream. Hopefully, you guys can hear me here. Again, what I'm going to do right now is I'm going to go into a quick. Let's pull it up here on the screen. So again, for all those who are tuned in, don't forget to give it a thumbs up. So So again, real job application. What real job application simply means is that once you land on the job, you want to plan your installation accordingly. You want to make sure that you don't overload your circuits. You don't start to mix your circuits up. Keep your lighting on lighting. Keep receptacles on receptacles. Make sure that your kitchen circuits are all individual circuits when it comes to your actual counter receptacles. Your stove receptacle obviously has to be on its own. There are some times when you have the receptacle for the gas, and so that has to be on its own also. So everything in the kitchen, make sure that it is on its own, and it will run smooth once you take the necessary steps in order to do what you have to do when it comes to the actual job itself. So again, I'm going to go into, let's see here. So I don't, okay. So let me show that there before I go on. So this is basically Appendix B. So this is the other rule for the 14 100, I believe. It says Appendix B explains that the limitation on continuous load 80% is to prevent overheating of conductors and overcurrent devices during long periods of operation. It clarifies that continuous loads are those expected to operate for 3 hours or more, and that both the conductor and the overcurrent device must be sized accordingly. Proper load calculations are required. Proper load calculations are required to ensure the circuit is not overloaded under continuous conditions. So I'm going to, and let's see here. So again, welcome back to the channel. I'm Fabian from Fabian Electrical Services Inc. And again, thank you guys all for tuning in to tonight's live stream. Again, we're on Real Job Explanation, and we're going to skip past that now, and we're going to head into the actual um, so this is going to be, let's go with this one here. So tool demonstration, and so again, what tool demonstration simply means is, instead of guessing uh, circuits like most people do, I normally use the circuit breaker finder. And again, this is what I use right now. And I am going to show you how I go about using it in real life with some videos here. So how this basically works is, you basically go to the panel, you plug in your transmitter, you plug your transmitter into the receptacle itself, and again, your transmitter is the one that's going to actually, so your transmitter is actually the one that's going to be giving you the signal. So again, I'm going to show you how I go about doing this on real job sites, testing in real time. So what this simply is a Kiwi transmitter KT301P, and what this does is basically it traces the circuit when you're having issues when it comes to troubleshooting and so on. We all know that troubleshooting can take us a very long time, Troubleshooting is one of the hardest tasks to perform. And again, what makes it hard is because when you are working alone, you have to travel back and forth. If you have someone else, it makes it a lot easier also. It avoids the unnecessary traveling back and forth. So what this basically does is this replaces the traveling back and forth, and it also comes with another part of it. And again, the other part of it is simply the actual um, so this is the transmitter, this is the receiver itself. And again, what makes it make my job so easy, I'm going to run a video here, and you're going to see how I go about using this actual tool in real life. um, and again, these videos here are fresh, so I'm going to run one clip here for you.
Stop guessing breakers. This is what I use on real jobs. Instead of flipping every breaker, I plug this in, go to the panel, and it tells me exactly which breaker it is. Saves time, no guessing, easy to use, plug and play.
So again, this is not the one I wanted to show, but I am going to show it, and you will see in real time how I go about doing this. So again, for all those who are tuned in, if you are tuned in on Instagram, I am on YouTube Live. You can swing over to the actual YouTube. Don't forget, who hasn't subscribed, you can subscribe to the channel also. This is where I go live every Wednesdays around 9 p.m. I do a full live stream. So again, for all those who are tuned in, if you are tuned in from Instagram, don't forget to like up the live. You can also drop a comment also in the comment section. And so again, that was how I normally go about troubleshooting in real time. I am going to show another video of in real time. That's not the video that I wanted to show, but I'm going to show you another video here. Top of the comment section here. Just click on the link, and there you go. So that's the Kiwi KT301P. That's how I go about using it in real time. And again, why this save time? Basically save time because you can um, use this. You can use this to cut down numerous time off the job site. It's what I've been doing. It takes, it, let's say a job is going to take about an hour or so. I can basically get this job done in less time with the actual tester. Obviously, with the scanner, using the scanner also does help to get the job done a lot quicker than usual. So again, I will show you guys another video here of it also. So again, this is tool demonstration. Kiwi breaker finder tester is called, and I'm going to run another short video here for you guys who are tuned in to tonight's live stream. Thank you guys all for tuning in. Don't forget to
Stop guessing breakers like this. Electricians use a breaker finder instead. Scan the panel. Correct breaker lights up. And it finds the correct breaker instantly. Kiwi sent me this breaker finder to test.
So that's how the breaker finder actually works in real time, people. For all those who are tuned in to tonight's live stream. So what I'm going to do now is I'm going to run another video here. Let's see here. So again, these are all short clip videos that I'm going.
Ever spent 10 minutes trying to find the right breaker? Electricians use a breaker finder like this. Scan the panel and it finds the circuit in seconds. Kiwi sent me this breaker finder to test.
Okay, so let's recap here. So these are real job site scenarios of how I go about testing the actual so again, these are real job site scenarios of how I go about testing my circuits, and so I'm going to run another short video here, and then I'm going to get on with the other stuff that I have here. So this will be the last video. Again, it's a 23-second video. I'm going to run this video, and then I'm going to get on with the actual rest.
Most electricians are using breakers wrong. A breaker protects the conductor, not the device. A 20 amp breaker can only carry 16 amps continuously. That's the 80% rule. Anything running over 3 hours, that's a continuous load. If you don't size this properly, you're setting yourself up for failure.
So we're going to head over to, let's see here, Kiwi, no. So segment 5. So again, segment 5, when to use it. Basically, it's saying when to use the tool. And again, the tool is used when there's a lot of mistakes going on. Mistakes happens a lot of times. Again, you have field inspections. So again, let me show you what field inspection. Let's say, for instance, you have 2 breakers, 3 breakers, for instance. One is a GE type breaker, This is what you call a GE type breaker. Um, I'm going to try to pull up, see if I can pull up big on the actual screen itself. Let's see here. Let me see if I can pull myself up a little bit bigger here. Not sure. Okay. So, for all those who are tuned in to the live stream, thank you guys all for tuning in to tonight's live stream. Again, this is what you call a 20 amp two-pole breaker. It's an actual GE type breaker. So with the GE type breaker, the GE type breaker only works in GE panels. So what that means is you cannot install a GE type breaker into a Snyder panel. So as you can see, this is a Snyder breaker. So you cannot mix match inside of one of the other panels. This is a Snyder. This goes into a Snyder panel. Again, this is a GE type breaker, 20 amp two pole. This goes into the GE panel. Again, you don't mix panels. You don't mix breakers inside of other panels. And again, this probably wouldn't go into the actual panel itself also, because as you can see, there are some blades here that are quite different to here. They are totally different to each other, but there are some breakers. For instance, you have the Eaton panel and the Siemens breakers, which you can use them in other panel in the same vice versa. Siemens panel, you can install a Eaton, but it is not correct because it voids the actual warranty. You can fail inspection. That's what makes you fail inspection. Having a Siemens breaker inside of an Eaton panel for your final, you are going to fail. It is not supposed to be inside of there. What else? If you have an arc fault breaker, for all those who are not familiar with an arc fault breaker, this is what an arc fault breaker looks like. This is a Snyder arc fault breaker. And what this arc fault breaker simply does is it protects the circuit. So protecting the circuit when it comes to the actual overloading of the circuit. Maybe the circuit's going to cause catch a fire or so on. This is what gets the job done. Once connected properly, as you can see, you have the actual white that goes on here, and you have the hot that goes here. So this is a arc fault type breaker, and this can only be used in a Snyder panel. So these are the same kind here. These are the same family. The only problem is this is an arc fault. This is a regular breaker. This doesn't protect the actual. This protects your wires, and they both will protect your wires. The only problem with this is designed to pick up any overheating on the circuit, trip the circuit out instantly, and allows you to get your job done accordingly when it comes to troubleshooting. So again, these are 15 amp breakers. They both go in the same panel itself, which is a Snyder panel. And I'm going to show you another breaker here that I have. This is actually a 20 amp two-pole breaker. So what can fail inspection also is improper connections. So when it comes to your breaker, you want to make sure that you do have the proper wire that's going to fit in here. You don't want to oversize the cable itself. Again, some breakers you have to pay attention when it comes to connecting your line here. Again, this is a 2-pole square D breaker, 2-pole square D, and as you can see, the blades are totally different to the actual other breakers that I have here. Two totally different breakers. Again, as you can see, this is a Snyder brand. This is a Square D brand. You can see the teeth here. The teeth is a lot different from this. So this can only go into a panel that is Square D, a specific panel designed for that. Um, Again, a 20 amp 2-pole, so improper wiring can cause you to fail inspection. When I say improper wiring, this is only designed to have a minimum of a 12 2-gauge wire on it. So if you install a 14-gauge wire on here, for instance, which is not supposed to be, because when you it all goes back to your rules also, the 8-104 rule and the 14-100 rule, where you have to have your overcurrent protection. So 14-gauge wire on a 20 amp breaker, it's not, you don't have any kind of protection. You've actually violated the actual code rule, and it can have you fail inspection. So improper connections is what gets you to fail inspection. Um, what is improper connection? Improper connections could be, you know, not using tape, sorry, morettes to make your connections. When I say morettes, a lot of people might not be familiar with it. So when you put two wires together, you use what is called, we call it a moret. They're range from 30s, if I'm not mistaken, 31s, 32s, 33s. I believe it bumps up to 35, and so on. So these little things here, when you don't have proper connection, meaning that, for instance, you take two wires, you want to make your connections, you take some tape and you actually tape it up, but those wires are hot. Um, those wires, when it comes to you actually making final connections, this is where this come into play. Morex, you twist your wires and so on. You make sure that your job is done accordingly. So again, this is a smaller one here. So improper connections will be basically not taking the actual wires themselves and moretting them with your morets to avoid someone else from having injuries or so on. We all know that electrical can, it does zap, and it's best to avoid all of that. So again, improper connections. This is one of them that you will see on jobs. The inspector will feel it. And when I say you do see it on jobs, for instance, I was working away on one job, and what basically happened was I went in to do a um, I went in to do a renovation job, and what happened was there was some wire taped up in the back of the actual taped up in the back. You know, they just had the actual morets. They didn't have no morets. The wires was inside of the wall. The wires was taped up Again, this is what you see on job sites a lot of times. So you do have to be aware of when you are doing renovation and you do start to see um, a set of cables are taped up and so on, you are going to be a little bit suspicious of the actual job that you're doing, because once you see a violation, one violation, two violations, you know there is bound to be a lot more violations coming. Again, those things will fail inspection. Those things will also have your home or your project shut down on hold for improper. There's a word for it. I don't remember the word for it, but yes, you can actually have um, the job shut down because of improper. Um, it's hazard. It's called when there's so many hazards going on um, in the home. You can have the job shut down for that. So that's where it comes into people not actually doing the job correctly. So a lot of times that will 100% of times it's going to fail the inspection. Why is it going to fail? Because it's not even meeting the actual code itself. It is specified in the actual code book um, when it comes to making morettes, making connections, when it comes to you having the proper arc fault breaker installed, when it comes to you actually using the correct size breaker. So again, when it comes to all these things, it is all set out in the actual code. But again, for all those who are tuned in, if you're tuned in for the first time, I'm Fabian from Fabian Electrical Services Inc. Again, if you're just joining, don't forget you can catch this on the replay. Also, don't forget, give it a like. Again, for all those who are tuning in on Instagram, thank you guys all for tuning in to the live stream and supporting the channel. Again, you can join me here over on YouTube where I'm doing the live stream. I will be doing a Q&A in about a couple of in a couple minutes or so. Once I'm done with this session here, I will go into the Q&A. So again, if you are tuned in for the first time to Fabian Electrical Services Inc., welcome to the channel. You can also drop your comment in the comment section also. So improper connections can fail inspection. Improper connections, like I said, is simply not having your wires, your wires twisted together, and also using the proper morass. And again, why it will fail inspection also. A lot of times you'll see people just take the wires, put them together, and they will put the morass on. It's not a secure, it's not a solid connection. When it comes to electrical, um, you want to make sure you have the connection solid as possible. I'm sorry that I don't have a wire here where I can show you that, where I can show you it. I don't have a wire here. I don't want to step away from the live stream, but I wish I had some type of wire here where I can show you what I mean. Again, what that is a solid connection. You do need a solid connection in order for the circuit to run smooth. So you'll find a lot of times you will go into a receptacle, and the receptacle, if you made connections, you'll find that maybe sometimes you plug in your light in the outlet, and the plug, the light starts to flicker and so on. That's not That's a wiring problem. That is a loose connection, possibly on the receptacle itself in the box. The backstabbing does that a lot of times. And what backstabbing is basically backstabbing is basically when you take your wires and you pop it into here. Um, you'll find that these connections here are not as strong as you screw it on. Again, this is a faster way to do your receptacles. So a lot of times people will backstab into here. Um, there's nothing wrong with it. Again, you have to position your wire in the correct manner so your wire is not moving when you put it in. It's all depending on how you actually install the receptacle. So when you backstab into the back of here, you have to kind of guide your wires accordingly. And when you guide your wires accordingly and you tuck it in, there's no loose connections here. So your plug stays tight and firm, and you don't have to worry about why is the lamp that I plugged in is flickering. So loose connections does cause that a lot of times. Um, Again, no load calculation. For instance, what is no load calculations? No load calculations is when you go onto a job and, for instance, you have a couple receptacles that the customer wants to install. You decide to install these receptacles, you lay out your room, you decide to connect these receptacles, but you don't know what is actually drawing. So again, when you have these type of receptacles, I believe a receptacle like this will draw about 5 amp, sorry, 0.5 or 1 amp or 1 amp. I believe this will draw. So imagine this is drawing 1 amp. Imagine that you have maybe 6 receptacles in your room. You want to put a TV, you want to put a computer, um, you want to start putting some other stuff that you want to plug in, maybe a heater or a little small heater. Again, it's all about load calculation, so you have to know what you're going to be dealing with when it comes to your load. Meaning that, yes, this receptacle draws 1 amp, um, but if you have about 6 receptacles on this circuit, and every time you plug something into one receptacle, it's going to be drawing its own current, so it's going to add up. So a lot of times, for instance, when you're on a commercial job and you do have a full set of drawings, it will tell you on the drawings. You just have to know how to maneuver with it when it comes to commercial drawings. Reason being is there's so many pages to go back and forth. You have all the information there. You even have what each device is going to be drawing. For instance, let's say you're working on a hospital job, you have tables, and so on. You have beds and so on. On that full set of drawing, it's going to actually tell you what it's drawing in those rooms. Uh, Again, a lot of you might not see it. Again, I've seen it over the years working in commercial, where you get a full set of drawings and it will lay out what you need to do on those drawings, and it's going to give you the full information you need. When it comes to residential now, it's a little bit different. Residential is not a whole lot of load going on. The only high power load you're going to have is your stove, EV charger, um, um, your your dryer, your air conditioner outside. So those are going to be your loads that you're going to have that are going to draw a lot when it comes to actual residential. So again, when it comes to proper sizing the circuit, you should always make sure that it's done correctly. Why? Because you want to make sure that when you do plug in that circuit, the person that's going to be using it is not going to have any issues once you've done the installation. So planning the job accordingly is very helpful. And guessing circuits don't really work in electrical. Guessing circuits is not something that actually works. Sorry about that, people. So guessing circuits don't work. Why guessing circuit don't work? Um, it just doesn't work. You can't guess your circuits, and that will have you fail inspection, because when you start to guess, you start to put circuits here and there. You start to run cables that you're not aware of. Um, you're all over the place. So a lot of times it's good to plan out your actual installation, and once you plan the job accordingly, it is going to go smoothly. Oh, you know what? Sorry, I didn't realize I had this. This must be echoing. Um, so sorry about that. I don't know if that was echoing, and it might have been echoing. Um, So that might have been echoing. I just realized, for all those who are tuned into the live stream. Again, thank you guys all for tuning in to tonight's live stream. Again, don't forget, if you are over on Instagram, you can join me here on the live stream on YouTube. I don't know if I think I would have pinned the comment in my video today. Um, so again, if you are over on Instagram, you can join over on YouTube. I am live on my actual YouTube channel. It is the same name. I think I would have pinned it in the video today. Again, thank you guys all for tuning in to the live stream tonight. Again, don't forget to like up the live, please and thank you. It helps with the actual channel itself. So again, for all those who are tuned in, don't forget to give the live stream a thumbs up. So I'm going to do a recap of the actual live stream today. I will do a recap of the live stream. So, recap. Basically, 8-104 is what I would have read through today. 8-104 and also 14-100. These are the main topics, code rules that I would have touched today. Also, you can find it in the Appendix B, where it will give you more of a definition of some sort in there. It will lead you to the appendix, and what happens when it leads you to the appendix is simply going to be giving you a rule in there that you need to follow. So that's basically what the appendix B does. So when you are sent to the appendix B rule, normally that's what's going to happen. So again, all those who are tuned in. If you are tuned in today from, if you are tuned in today, if you are from Canada, you can drop a comment in the comment section. Let me know where you guys are tuned in from today. Again, if you are from the United States, you can drop a comment in the comment section. And if you are also tuned in from the Caribbean, drop a comment in the comment section. It doesn't matter wherever you guys are from, you can drop your comment. This is the, I am going into the Q&A segment where you can drop your comments in the comment section. I will be asking them live tonight. So just a few details of what I did actually go through tonight on the live stream. So tonight, 8-104, 14-100. I also would have showed you guys, what feels inspection, what will make you feel inspection. Basically, what will make you feel inspection is having the wrong breaker installed. Let's say you have a 15 amp breaker, for instance. You have a 15 amp breaker. You want to make sure that a 15 amp breaker is supplying a 15 amp circuit. What that means is you want to make sure that anything that you're turning on, let's say it's a receptacle, the receptacle has to also meet up with the actual breaker itself. So if this breaker is rated for 15 amps, your receptacle itself has to be also rated for 15 amps. Very important. So if your receptacle is 15 amps, your breaker is also 15 amps. So you cannot have, if your receptacle is 15 amps, you cannot have a 20 amp breaker on a 15 amp breaker. It doesn't work like that. You can actually burn this receptacle out. You can actually burn also the wires also. So keep in mind of that. And again, when it comes to, that's some of the stuff I would have went through tonight. Improper breaker sizing, improper wire when it comes to the wiring. Also, you have to keep into effect the wiring. It does, for some reason, um, tend to, you can run into issues, like I said. Once the job is done correctly, you can have a smooth day at the end of the day. But again, it all depends on how you go about your task, and if you go about your task not trying to use the OESC 2024 code book, that's when you're going to run into issues, people. So never forget that. So again, also common mistakes, you know, I also would have showed the Kiwi breaker finder tester. So again, for all those, if you missed it, this is what it looks like. It's a basically it's called a KT301P transmitter. Again, how it works is you can test, and you can on it and you can test it, and you do have the two buttons here. One is fault. One means that that circuit is no good. The green means that the circuit is simply powered on and correct. And again, when you are using this tester at the panel, you're going to find that when you do turn this off, eventually, when you do turn off your breaker at the panel, this is going to flash. It's going to flash green. When it's flashing green, it's basically telling you that the circuit is off. So this is the Kiwi breaker tester finder. And again, this is the transmitter. Sorry, this is the receiver. They both go in hand, and that's how you normally will use them together. I would have shown a couple short videos tonight on it. For all those who are tuned in, you can catch this on the replay, or you can also head over to the channel. You can check the playlist that I have under um, breaker tools. You'll find the actual shorts and the actual long form video that I did drop on the actual breaker finder tool. Also, don't forget you can the link is pinned in the comment section for all those who are tuned in to the live stream tonight. The link is pinned in the comment section. So that's basically what I would have covered tonight on the live stream. That is an easy breakdown of what I would have covered tonight. And what I'm going to do right now is I am going to 1 second, people. Sorry about that. What I am going to do is I am going to, and then we will have covered round breaker sizing, yes, no load calculations, improper connections meaning when you don't take the time to do your connections properly. When you don't take the time to do your connections properly, what basically happens is it ends up being that you're going to run into troubleshooting issues. No one wants to troubleshoot at the end of the job. It takes up too much time, too much headache. And again, if you are going to troubleshoot at the end of the job, this is what I've been using to troubleshoot, and it works fine. It gets the job done fast and accurate. So, yeah, this is what the Kiwi breaker finder tester. So, guessing circuits. You don't want to guess circuits. Avoid that. And I am going to go into the Q&A for all those who are tuned in. You can drop your comment if you want to. You can drop a comment in the Q&A. I am answering. I will be replying live tonight, so you can drop a comment. So, what are you guys struggling with on jobs? Anyone had breakers tripping randomly? If you had breakers tripping randomly, drop a comment in the comment section. I will reply live stream tonight for all those who are tuning in. So again, if no one, it will drop a comment. I will run. I'm not going to. Maybe I will run a couple short videos before I log out for all those who are tuned in to the live stream. You can, don't forget to tap on the screen. So if no one, I'm going to play a couple shorts here for all those who are tuned in. If you are tuning in for the first time, you are tuned into Fabian Electrical Services Inc. Again, thank you guys all for tuning in to tonight's live stream. So let's see here. So this is for all those who missed the live stream on the opening.
If you're still guessing breakers, stop doing this.
Okay, so that is one little short. I will run another one here for all those who are tuned in. You're tuned in to Fabian Electrical Services Inc. Again, don't forget to you can join the channel. You can also join me on the live streams on Wednesdays around 9 p.m. That's when I normally go on the live stream. So again, for all those who are tuning in, don't forget to tap on the screen to actually um, like up the live. It does help with the channel itself. Okay, so I am going to run one more short here, and that it will be it for the live stream. So again, this is how I go about troubleshooting in real life using this actual tool itself. This is how I go about using the actual tool. They are a wrong way and a correct way. Obviously, I am going to take the correct way of doing the job accordingly and making sure that it is done to the actual code itself. So again, for all those who are tuned in, if you are tuned in from Canada, if you are tuned in from United States or even the Caribbean, you can drop your comment in the comment section. It is live Q&A. Drop your questions. I'm here to reply to them live. If not, I will be ending. Hmm? I will be ending the live stream itself in a couple of minutes here, guys. Okay, so okay, so that's about wrapped up for tonight's live stream. So appreciate everyone that came through tonight. Um, If you got value from this, make sure you subscribe. I'm breaking this down every week. And remember, stop guessing. Start doing it the right way. I'll see you on the next one. And again, for all those who are catching this on the replay, the next video on the screen or even the next playlist, click on it and it will take you to the previous videos that you would have missed or the live stream. So again, thank you guys all for tuning in to the live stream tonight, and I will catch you guys on the next live stream.